Good morning. Today we're going to go over the skeletal system. Previously in this chapter we've gone over the integumentary system, which was made up of the hair, nails, and skin, and how important they are for the body. We went over the muscular system, and as most of you know, the skeletal system works very closely with the skeletal system for movement. But the skeletal system does a lot more than that. Some of the other functions of the skeletal system include making red blood cells and storing calcium, just to name a few. But before we move on, let's just look at a diagram of the skeletal system. So, the diagram that is now on the screen shows you many of the major bones that we find in the body. First we have the skull, which is also known as the cranium. We know that's for protecting the brain, as well as other delicate organs such as the eyes. We also have the clavicle, which is the collarbone. We find that just at the base of where the neck is. There's the sternum, which is the breastbone, which we find in between the ribs. The humerus, which is part of the arm. We have our ribs, which protect many of the inner organs of our abdomen, including the lungs and the heart. The radius and the ulna, which are part of the lower part of the arm. The radius is a little bit thicker than the ulna is, so keep that in mind when trying to differentiate between the two. The radius is usually found on the outside of the arm. We also have the femur, which is the longest bone in the body. This is supposed to be referring to this bone. We have two bones in the bottom. We have the fibula and the tibia. The tibia is the shin bone, and then you have the fibula, which is the bone just behind it. This diagram doesn't mention it, but there are also the phalanges, which are the fingers and the toes as well. There are a bunch of other smaller bones as part of the hand and the wrist area. The smallest bones in your body are actually found in your ear to help with sound, so keep that in mind. You will not have to know every single bone in the body, and you'll see why in a few minutes when I get to that point. Many of you have noticed, probably, hopefully, that many organisms have very similar bone and skeletal structures. This is usually a good sign of evolution, which is something you'll be studying in 8th grade. It means at some point there was a common ancestor that they all developed from. We call these homologous structures, meaning same structures. And as I said, same structures usually means that they're closely related, or at least somewhat related in evolutionary history. Now, take a guess. How many bones do you think you have in your body? Take a few moments and make it a number guess. Now, I think you'll be surprised to find out that you actually have 206 bones in your body. And that number is actually greatly decreased from the time of your birth. When humans are born, there are about 300 bones. But over time, the bones begin to fuse together. So a good example of this is the skull or the cranium. There are many immovable parts that were once movable. They fuse together. This is why babies have what we call the soft spot. It's because that is a section of the skull that has not fused together. That's why babies' heads are so delicate. There are other bones throughout the body that begin to fuse, and the cartilage that is there, that is soft and used to cushion any possible damage, begins to harden and begins to be replaced by bone. As I've said before, the skeletal system works very closely with the muscular system. Both are needed for movement. Now, it isn't just that the muscles lie on top of the bones. There are actually connective tissues called tendons there, and the tendons connect the skeletal system to the muscles that are nearby. You may have heard of something called tendinitis before. Usually people will get this as an injury, and it's an injury of that connective tissue that keeps the bone attached to the muscles. Now there are 5 different functions that we're going to look at. The first function is support. It's a framework for the body. Protection for the internal organs. Movement, which we've already started discussing. Storing of minerals, mainly calcium and phosphorus. And then production of red blood cells inside the bone marrow. So, So we know that without our skeletal system, we would easily fall apart. We would be one big puddle on the floor. The skeletal system is there to make sure that we are able to stand upright, and therefore, because we have that support, we're able to move around as well. As I said, in conjunction with the muscular system. Also protection. Now, if you think about it, you have many delicate organs inside your body. Just think about the abdomen, where you have your heart and your lungs right behind the ribcage. The ribcage is there to protect us from injury. So let's say you're in a car and the car stops short. The ribcage is there to protect your heart and lungs from any sort of possible damage, in addition to a few other things such as layers of fat that surround the organs for shock protection, but mainly the bones are there to try and stop any sort of damage from happening during an accident of any sort. Storing of minerals, so calcium and phosphorus help keep the bones nice and strong and firm. You probably heard so often that you need to have enough calcium in your diet. It's especially important when you're younger. I'll go over some sources of calcium later in the PowerPoint. It's vital for many, especially for women, because later in life, if women have not had enough calcium in their early years, they can have something called osteoporosis. Osteoporosis leads to bones being easily broken. Also, we'll see in some diagrams in a moment, but in the middle of most bones are hollow, and in the middle of many of the long bones of the body is something called bone marrow. The bone marrow is an area where red blood cells are produced and stored until they enter the blood as a means of carrying oxygen. The red blood cells are replaced every so often, I believe every 180 days, so your bone marrow is making a constant supply of them. If you don't make enough red blood cells, or you don't have enough in your blood, that's called anemia. There are multiple reasons, or you could have anemia, or you may not have enough iron in your diet also, but if you don't have enough red blood cells, that'll lead to you feeling lethargic and tired all the time. There's the structure of the bones, so bone is not solid, as I previously said. There are there's some differences between what you may believe bone to be and what it actually is. So there is the compact bone that you guys are probably more familiar with. It's the part of the bone that's pretty solid and gives strength. There's also towards the end of the bone something called spongy bone, and this is where bone starts to get more hollow. One reason bone needs to get more hollow is to add in blood vessels. Blood brings nutrients and oxygen, and bone is no different. It's made of living cells that require oxygen and nutrients to function. Also in the middle, we also have the bone marrow, which usually takes on a yellowish color. That's where the red blood cells are made. So as I was saying, why are they hollow? They're hollow for many reasons. Another reason I didn't mention is it makes them lighter. If they weren't hollow, bone would be way too heavy for us. Hollow bone also gives more strength. That may confuse you, but it gives a certain flexibility. If bone was completely rigid, it would be easier to break because it would not be able to take on pressure or strain from our movement. So if you want, try this. Take a piece of paper and roll it up so that there's about an inch of hollow space. Take another piece and roll it tightly so that there's very little space. Place a book on top of both pieces of paper and see which one can hold more weight. And If you have any questions about that or you want to comment on it, leave a private comment or a public comment on this post for today's lesson. Another thing that we need to discuss are the types of joints. So we're going to look at 5 types of joints, although there are more of them. Now, joints is mainly where bones are able to move. It allows for motion. First of all, bones are held together at ligaments. This is another type of connective tissue. So you'll see that your bones are not connected to each other. They have a connective tissue there that helps allow for movement, as well as cartilage at the end of each bone for cushioning. So the types of joints that we're going to look at are movable joints. We're going to be looking at ball and socket joints, hinge joints, gliding joints, and these are some of the examples that we will be looking at. So first, here we have movable joints. Now I mentioned that when you're born, your skull is very soft. There's a soft spot, and that's because the different bones that make up the skull fuse together over time. The cartilage in between the different bones is replaced by bone as you're maturing after your birth. So these bones in the head within the first year become immovable. Then we get to the movable joints, and those are the pivot joint, the ball and socket joint, the hinge joint, and the gliding joint, and we find them at different points in the body. So the first is the pivot joint. The pivot joint allows one bone to rotate inside of another bone that doesn't move. The head where it meets the neck is a very good example of this. So you'll see that the cranium is able to move where the cervical bones of the neck are not able to move. Keep that in mind. The next type is the ball and socket joint. Ball and socket joint allows for a great range of motion, usually in some form of a circular motion. This is where one bone ends up in a cup-like cavity. So one example of that is the shoulder. You'll see at the shoulder joint that your arm is able to move around in a circle because of the cup-like cavity that the end of the bone is in. We also have a hinge joint. The hinge joints are found where your elbows are and where your knees are. They allow for a back and forth motion of some sort, kind of like when you're throwing a baseball or kicking a soccer ball. That's the type of motion I'm referring to. This motion is slightly less than a ball and socket joint. We also have gliding joints. So gliding joints is when we have a back and forth motion also. One bone slides over another bone. We find this at the wrists and the ankles. Joints are highly protected by a material called cartilage. Cartilage is very soft. It's there for cushioning and for reducing friction between the bones. You'll see that in the disc-like structure between the vertebrae of the spine. We find it at our elbows, our knees especially, because when we're moving and we're walking, we need a lot of cushioning there from the impact of our legs hitting solid grounds. Let's see, it's a good way to prevent injury. Now, sometimes cartilage does wear down over time, and that's where we see that we can end up with something called arthritis. This is another disorder. It actually is a very large name that covers 100 different diseases. Itis is usually just a suffix that means swelling, so arthritis is referring to the swelling and the pain and stiffness that you see at joints. It can be pretty obvious depending on how advanced the arthritis is. Ways to keep your bones healthy, making sure that you're eating certain foods such as milk, yogurt, cheese, salmon, nuts, fruits, leafy green vegetables, exercising usually helps build the strength of the bones, getting enough vitamin D, which works with calcium, and not smoking. If a bone breaks, blood initially clots around there. It brings a lot of nutrients to help the bone build back up. First, the soft cartilage will build up, and then after a while, bone cells will start to replace that cartilage. There are other websites that you can refer to, as well as